In lab 6, we start out with writing our comments here that just tell how we assemble, link, and execute it. We would also have our name and the title of the lab. After this, we need to write what syntax we're going to be in. So we need to use an .intel underscore syntax with no prefix. And then after this, we need a .data because we need a .data section. We're also going to need a .text section, so we can write that out now by doing .text and then have a .global underscore start and then our underscore start here with a space between global and start. In this lab, we will have one introduction label and it will look like this. It'll say introduction and have ASCII greetings. I am the Gryffindor Avenging statue. We have 2 /ns for spacing and then a /0 to end this line. After this, we need to have 5 options for a menu. And we need to write out these options like this. These are just for spacing. It's not part of the code, but all of this is part of the code. And the reason why we cannot write it all in one label is because we are going to need to call these individually later. We have /ns on each of these for spacing and also a /0 on each of these because we have to close this .ascii. And then on this cancel line, which cancels the order, we have 2 /ns here. After this, we need to have these 2 menu options. And these both are going to be related to all of this up here. We have a .quad quill, which is going to be related to this first one, cauldron, which is going to be related to this cauldron, wand related to here, and the same thing for the other 2. We also have the costs, which is going to be actual numbers, and it's going to be .quad, which is going to store 25, and it's going to be linked with this, .quad 85, which is going to be linked with this, and the same for the rest of the 3. We're going to have to actually link these later since they don't automatically link to each other just by doing this. After we have our options and we also have our menu parts, we need to have the question, how many nuts are you feeding it? And we are going to store this value in a .quad like this. We need to use this later. And after this question, we are going to have a label with selection. And it's saying enter our selection, enter your selection. The user is going to input which one of these options that they want. However, we don't need to store it, which is why we don't have a .quad under it. We're just going to use it in our .text section. After this, we're going to have another prompt that says you selected, and then it is going to print out which of these that the user selected. Lastly, we need this last part, change 1 and change 2. This is going to be on the same line. We just have these double /ns just like here for spacing at the very end. We don't have anything in here except for a /0 because we need to end this ASCII. Because in between your change and nuts, we are going to have to output a number, and we are also going to do this in our .text section. So this is all for our .data section currently. We have this introduction part. Then we have these options that we will present the user. We are going to link these menu items right here to these options. Then we are going to ask the user this question. And this question is basically going to be how much money that the user is going to be giving this, because this is like a vending machine. And then these are the different prices. And then the selection is which one of the selections they are picking. And then we are printing out which selection they are picking, and then we are giving their change if they have change. If they give an invalid option or they try to buy something that they don't have enough money for, we are going to use a loop later to keep prompting them until they give a correct answer. So for our starting part, we just want to print out the introduction. So we're going to load the effective address of introduction, which is our label, into RAX and then call print cstring to print it out. After this, we are going to call each one of our options individually. And then after we call each one of these options individually, we're going to ask the question, how many nuts are you feeding it, which is the currency. So how much currency are we giving it? This is Harry Potter theme, which is why it's pretty weird. But we are asking this question, we are loading the question into RAX, then we are calling print cstring to print it out. After we do this, we need to get the user input because we are asking them how much they are feeding it. So we're going to use a call scan int, and then we are going to move this value into our .quad, which we have as nuts. We will move into nuts RAX because RAX is going to store our scanned int. After we do this, we need to ask the user to enter their selection for the vending machine, and we are just going to load this and print this out. This is what we're printing. And then we need to get their input. So we're going to have to use a call scan int. Since in our menu, this is what we have. These are our menus, but each one of these lines starts at 0 because each one of these make up a byte, and a byte goes from, or it starts at 0 and it goes to 7. So if we input the option 1, it would be cauldron, and if we input the option 4, it would be cancel, but we want options 1 through 5. So what we're going to have to do is subtract 1 from our user input because our indexes start at 0. So we can go back down here and we'll do sub, and we want to store this into RAX still, so we'll do RAX comma 1, just so we subtract 1 from RAX. And after we subtract 1 from our user input, we are going to get 1 through 5 instead of 0 to 4. And so now we can move this into a register. We'll use RDI for this. We'll use move RDI comma RAX. So now RAX is being stored into the RDI register. The RDI register is typically used for indexing, but we could also use any register that we want. After this, we are going to print out what they selected. So what we're going to do is print out just that. We're loading the label you selected into RAX and then calling print cstring to print it out. After this, since we're using direct indexing, what we need to do is take the value that's in RDI and get that specific place in our menu. To do this, we are going to have to store it in RAX and then print it out. So we're going to use a move RAX comma 2 brackets like this, and then we called our label here items. So we want to print out items because we want to print out the selected value. Again, because each of these quads are linking to each of these. So we need to print out what's associated with this dot quad. Into RAX, we are going to move items plus RDI times 8. And the way this works is that if the user inputs, when it says enter your selection, if the user inputs 1, we are going to subtract 1 from it because we have this. And then we're going to move our RAX, which is now 0, into RDI. And then we have items plus RDI, which is 0 times 8. So we have items plus 0. So with items plus 0, that means it's going to look back into this menu we created, and it's going to get the dot quads starting at 0, which is this. Each of these dot quads go from 0 to 7 because they're 8-bit, 1 byte, and each dot quad is 8 bits. So 8 bits for this would be 0 to 7. 8 bits for the next one would be 8 to 15. 8 bits for this one would be 15 to 23, and so on and so forth for the rest of these. And this is the same thing that's in costs. So after we do this, all we want to do is print the string. We are printing the string even though we're using move, because the string right here is associated with this dot quad. So we're going to use move because we have a dot quad here. However, we want to have a string printed out, so we're going to use print cstring. So underneath this, we are going to we need to call print cstring. And this is it for the uSelected part. After this, we are going to end our program. And to end it, we need to print out the change, the amount of change that the user has. So we can label this end, and then print this first right here. We're loading the effective address of change 1 into RAX and then calling print cstring. And this is going to be your change is. And then we're going to print out our change and then nuts /n/n/0, which is just spacing and then the ending for change 2. So we can first write this out and then put some spaces in between these. Now we can do our actual math inside of here. It's going to be similar to what we did right here, except instead of calling items, we want to call the costs because the costs are associated with each of these. To do this, we need to get the value that the user input and store it into a register. We are going to move into RAX, comma, nuts, because right here it stores how many nuts the user is feeding it. This should just be MOV, not MOVE. And then after this, we are basically going to do this same thing, except since we already have something in RAX, we're going to change this to RBX and change this to costs. So we're going to have move into RBX, comma, the brackets, because we have multiple math operations in here. And then we need to do costs plus RDI times 8. And again, RDI is just storing the inputted selection from the user. Now that we have this, all we need to do is print out the integer at this point, because the integer is this right here, and the string is this. So instead of calling print cstring as we did up here, in here we need to call print int. And then we can put a space in here just for spacing. But before we print the integer, we need to subtract the REX, which holds the nuts that the user inputs, from the cost of the product in the vending machine. So to do this, we are going to have sub REX, comma RBX. And the reason why we are storing nuts in REX and the reason why we are storing the cost into RBX is because when we subtract this, we're subtracting this against RAX. And REX, which is the nuts, always has to be higher than RBX, so that way we don't get a negative number. However, there is an issue. When we enter how many nuts that we are feeding it, we can enter in 10. If something costs 25 though, we don't have any bounds checking here to make sure that they can only purchase something that is less than 10. So what we can do is write a while loop around this part to fix that. First, I'm going to go here and do a call end program so that after we run this, our program will eventually execute. Now we are going to go back up into the enter your selection part and code the while loop for this. First thing that we need to do is actually create a label for this so we have something to loop back to. We'll call it loop, and then all of this code is going to stay the same. Nothing here is going to change. We're just going to go below it right here, still a part of this loop label, and under here all we're going to do is do the same calculation we did right here so that we get the cost of the current item, except we're going to do it right here. That way we can compare it and loop back if it is a value that's over what the user input. So we will just move into RAX cost plus RDI times 8, which is basically the same thing that we had right here. We're storing it in RAX this time though, because we don't have anything else stored in here. So we are moving this into RAX, and after we do this, we need a compare statement. So we're going to write compare, and we need to compare how many nuts the user input, this value, how many nuts we are feeding it. We need to compare nuts to RAX, which is the cost. So we'll do compare nuts, comma RAX, and then if this is the loop part, if our value nuts is less than our RAX, we need to loop back here. So to do this, we'll just do a JL, which is jump less than, and then our label, which is loop. And this is all the code needed to answer the last two requirements of this lab, because it checks if the user has enough money, and it also checks for invalid input. Since we only have 5 options here, the prices for any other values inputted is going to be some huge number. Therefore, in our loop, this covers input validation for enough money and valid selection for the selections in our vending machine. And going back down here, I see that I've spelt cost wrong. Instead of saying cost, this should be costs. That's the correct spelling for this menu option. And before I run it again, this is the entire code. This is the .data portion, all of this right here. This is the last part of the .data section. And then this is the .text section. This is the beginning of it. This is the loop required for the extra credit. And then this is the ending portion. So we'll exit and save, and then reassemble our code, relink our code. No errors here, so we can continue by doing /a.out. And we have our greetings, we have our menu options, and then we have how many nuts are you feeding it. We'll try 26 to test for our invalid input. We need to enter our selection. If we enter 6, well, that's not valid, so it's going to continue going. We'll do 10, still not valid. If we did 0, still not valid. If we did -1, still not valid. So our invalid input works for valid selection. Now we need to see if these selections will still execute, since all of them except for 5 and 1 are greater than how many nuts we are feeding it. So we'll try 2. Doesn't work, which is good because 2 costs more than how many we are feeding it. Same thing with 3 and 4. If we want to buy the only thing that we can, which is quill and ink, we press 1, and then it says you selected 1 Quillen ink, 25 nuts, and then our change is 1 nuts because we have 26 subtracting from 25. If we wanted to try this again, we could just do a.out, and we will put in a number like 43 or 45. Enter our selection. Again, we can just input our selection. Any random number will work. So if we do 78, still won't work. So what we can do here is start entering things. We're going to test 2. Too high doesn't work. If we test 4, which it's under, it'll work and it will give us 3 change. So we'll do 4. So it says for every flavor bean, 42 nuts, and our change is 3 nuts. If we wanted to test if we can cancel this, we will just a.out, run it again, and we can say 800 nuts, but we don't want to buy anything, so we'll press 0. Pressing 0 actually would give a 0 option here, which is not here. We have to press 5 to cancel the order. So if we input 5 and press enter, we have selected cancel order, which is 5 nuts, and our change is 800 nuts, which is what we've started with. So this is the code for the entire lab, and this is the output for it.